And so when you are multiplying and dividing fractions, the first thing you have to do, class, is you have to convert all the numbers to fraction form. Okay? So, for example, if you have a mixed number, you have to change it to a top-heavy fraction. Alright? If one of them is a decimal, and one is a fraction that is a repeating decimal, and you can't use that repeating decimal, you have to change the decimal, the other one that's a decimal, to a fraction. All numbers have to be fractions. How would you write a whole number as a fraction? If it's a whole number?
Like, you would do like 8 over 1.
Yeah, you just write it over 1. So if you have a whole number, you have to write it as a fraction by writing it over 1. Okay? So that's the first thing you have to do. Look at this example. Copy on this example in your notes. 8 times 3 eighths. 8 times 3 eighths. Actually, let's make it 3 and 3 eighths. Then we can practice both. So the first one, we have to write 8 as a fraction. So write 8 over 1. How do you write a mixed number as a fraction? 8. Yep, the whole number times the denominator. And then what?
And then add the whole number to
No, add the
top number to the bottom.
No, you
Yeah,
add the
like,
bottom number to the top.
You're very bad at cheating,
Right,
Nate.
why don't
You
you-
gotta listen
Why
better.
don't you pay attention instead of goofing around with Alex, okay? So, you take the whole number. What you're doing is this. You're trying to find how many total pieces you would have if you cut them up all into eighths. You have 3 eighths. What if you took the rest of these wholes and cut them up into eighths? Then you'd have, what, Brett?
27 eighths.
27 eighths. Okay?
Wait.
Oh, what 8 times 27?
Because 8 times 3 is 24 if you took all the whole numbers and cut them up into eighths. That'd be 24 plus the numerator
So you do 8 times.
plus the number of pieces you already have, and that's 27. Hey, you guys, listen, you're 1 strike away from an extra assignment, so just pay attention right now, okay? Write down this example. Then, we're multiplying. So, you could skip step 2, but it would be a lot easier if you factor out before multiplying in this case. Here's how you factor out. You look diagonally. Look at the top numbers and the bottom numbers. And you can see diagonally that you have 8 over 8. In other words, if we use the rules of math, we could write this as 8 times 27. And we can rewrite this as 8 times 1 because of the commutative property. Right? Using the commutative property, we rewrite, instead of 1 times 8, you write 8 times 1. Does everybody see that? And then 8 over 8 crosses out. And you're left with the answer.
27 over 1.
27 over 1, which is just 27.
I was right.
Okay? So by factoring out, we didn't have to multiply 8 times 27 and then reduce the fraction into lowest terms. We just cross out the 8s. And you can do that even without rewriting it. But I wanted to show you why it works, why Because the commutative property, we can rewrite and we can factor out the 8, okay? Now, let's go on to dividing fractions. Copy down these receivers. You already have the numbers in fraction form, so that part is the same, okay? Here's the part that's different. Instead of dividing the fraction, what you have to do is use the reciprocal of the second number. You may want to stick around for this, Bryce. Use the reciprocal of the second number.
What was what now?
You use the reciprocal of the second number, so you flip it, and then change the multiplication. Alright? So, remember, a reciprocal is the fraction flipped upside down. Okay? So, if we're starting with 1/4, we would use 4 over 1, and then multiply. If the second number is 1 1/2, you'd first convert it to 3 halves, and then use its reciprocal of 2/3. And then multiply. So if we have one like this, 8 divided by 3, I'll use the same numbers, 3 and 3/8, okay? 8 divided by 3 and 3/8. You first have to rewrite them as fractions, so we know that this is 8 over 1, and this is 27 over 8, okay? But instead of multiplication, we have division. And so what we have to do in order to find the answer, we have to change it to multiplication and rewrite the problem as 8 over 1. This number, the first number in the problem, stays the same. The second number, the divisor, is flipped to 8 over 27. And then we multiply. Now, can we factor it out first? Not until it's written as multiplication. You can't factor out until it's written as multiplication. So in this case, you can't factor anything, because there are no common factors with 8 and 27. And there are no common factors with 8 and 1. We can't reduce that anymore. So we have to do 8 times 8, which is 64, and 27 times 1, which is 27. Okay? Go to your worksheet if you're done with these notes. To start on this, I'll leave the notes up here, but I'll talk you through the first few. Number 1.
Pick and choose. I can't do both of
I'm going to leave these notes up here so you can copy them later if you want to work through this with me. So, you start with 7/9 times 3/7. What numbers could you factor out? What numbers could you reduce?
7 and 7.
Yeah, cross out the 7 and 7, write 1.
And also the
Cross out the
3 and 9.
3 and 9 and write
1/3.
1/3. And then multiply.
What's 1 time?
2.
1 times 1, 1 times 1.
Alright.
2.
It's just blue.
What do you have to do first in number 2? Convert them all to
Fraction.
No,
fractions.
So it'd
You
be
can't use the decimal because 1/11 is a repeating decimal. You can't get an exact answer unless you use the fraction. Okay? So you have to convert them to fractions. The first one, 2 and 1/5 is 2 times 5 plus 1, which is 11 fifths, times a negative 12 elevenths. Is your answer going to be positive or negative?
Negative.
Negative, yep.
Positively negative.
Now, notice that you can factor out the 11s. Reduce 11 over 11 to
1 and 1.
1 and 1.
Negative 12.
I put
Negative 12 fifths.
I put 21.
Yep.
I changed it.
Skip down to number 5. 6 elevenths divided by 4 elevenths. Is your answer going to be positive or negative?
Negative.
It's going to be negative because we have a negative divided by a positive. Then you keep negative 6 elevenths the same, and you flip the 11, the second fraction, so it's 11 over 4. All right?
Is that the 11? 6.
11 over 4. Let me show you.
I got it right there. 6 and 3. 2. Simplify.
So it's negative 6 elevenths, and then change it to times,
Still like it.
and use the reciprocal of the divisor. Then reduce 11s to 1 and 1. 6 and 4 can be reduced to 3 and 2, because we factor out the 2's. And then multiply. 3 times 1 is 3. 1 times 2 is 2. And it's negative. Oh,
Technically, he still did.
okay. Do number 7, I mean. First convert it to a top-heavy fraction. Negative 21 over 5. Keep the division sign. And change the second one.
Negative 7.
Negative 7 over 4. Then rewrite it.
Yeah, we can.
Negative 21 over 5 times negative 4 over 7. Once it's in multiplication, I can reduce and I can factor out the common factors. So negative 21, I'm sorry, just keep these, just treat them like positives when you're factoring out. So just change the numbers to 3 and 1.
Should Mr. Rotsky,
And
shouldn't
make the answer positive.
shouldn't the 7 be on the top?
No, because the 7 is the top heavy fraction of negative 1 3/4.
But then why is the 7 the 21 on the top?
The 21 is from this one.
So
Negative 4 and
if
1
there's
fifth.
2 negatives, the second one has to be flipped.
No, it's division. And so the second one has to be flipped.
Oh, so any division the second.
Any division problem,
So just even if it's positive.
you have to change it to multiplication and flip the second fraction.
Even if it's positive.
Even if it's positive, yep. Positive and negative do not matter in this. All right, your assignment is on the practice side. Okay? Just do this first column, 1 through
10 even. 1 through 10
1
even.
through 22.
All of this?
So this B is right here.
Just this side?
Yep, just this side.
That's like nothing.
When you don't want to do math. Nobody likes 21 or 22.
21
Nobody likes math. Nobody likes it.
And I was kidding too. That's actually.
What did you get?
That's numbers. That's it.
I'm like, I hate math.
I just put it in.
That's it, location. No, you can't do it.